This video introduces how we combine and subset SAS datasets. We've seen the set statement before. We used it when we were working with the import wizard, bringing in an Excel spreadsheet, and we wanted to create a copy of our SAS dataset into a new SAS dataset. We've also looked at the set statement in relation to working with permanent SAS datasets. So the set statement reads a SAS dataset, and it replaces the INFILE and INPUT statements used when reading in raw data. So here we have an example where we are creating a SAS dataset called new, and we're copying in another SAS dataset called old, and we're keeping a certain list of variables. So the keep statement is optional. We don't need that. And so basically what we're doing here is we are creating a new dataset called new that has all the variables in the var list and has the same observations as the SAS dataset old. Is new a permanent SAS dataset or a temporary SAS dataset? It's a temporary SAS dataset because we don't have a libname statement and we don't have a two-level name in our data statement. The set statement can also be used to concatenate or stack SAS datasets. So we can actually stack two datasets together and create a new SAS dataset. For example, if we had a dataset that were males and a dataset that were females, we could create a new SAS dataset that combined males and females by using the set statement. So here's a general example of our code where we start data new dataset and we're stacking dataset1 followed by dataset n. The observation order is determined by the original order. So dataset1 is going to be the first set of observations in our new dataset, and dataset n is going to follow the observations that were in dataset 1. Also, if one dataset has a variable that's not on the other, observations from the other dataset will be missing for that variable. So let's say that we were concatenating two datasets, a male dataset and a female dataset. And on our female dataset we had a variable called LMP, standing for last menstrual period. Now that variable might be on the female dataset, and when we concatenated it with the male dataset, that variable would then be on the combined dataset, but for all of the male observations, that variable LMP would be missing. So when we combined and make a new dataset, all the variables are on the new dataset, but that does not necessarily mean that all of the variables will have complete data. It depends on whether there was data in the original dataset for that particular variable. Another useful statement when we're combining or subsetting SAS datasets is the output statement. The output statement tells SAS to output the current observation to the SAS dataset. And the basic syntax is just output and then the dataset name. Note that there is an implied output statement at the end of the data step. If SAS sees an output statement in the data step, then SAS will only output when you tell it to. Otherwise, if there's no output statement in the data step, then SAS just outputs the observation when it comes to the end of the data step. So here we have an example of where we want to make multiple data sets in one data step. So notice here in our data statement, we are listing out 4 different temporary data sets that we want to create within this one data step. And we're calling the 4 data sets Clinic A, Clinic B, Clinic C, and Clinic D. And we're bringing in the permanent SAS data set SE score. And then our statements say that if clinic equals A, then output clinic A. So if the observation that we are processing is from clinic A, then that particular observation will be outputted to the new SAS temporary dataset called Clinic A. If a particular observation is from Clinic B, then that particular observation will be outputted to Clinic B, and so forth. So here we are creating 4 different temporary SAS datasets, and on each of those datasets, the only variables that will be on them are the 3 variables PTID, for patient ID, clinic, and RAN date, which stands for randomization date. So again, if SAS sees an output statement in the data step, then SAS will only output when you tell it to. And here is the log from this program. So we see here there were 100 observations read from the dataset mylib.ses score. So there were 100 observations read from this permanent SAS dataset. And then for Clinic A, 18 observations were outputted, and there were just 3 variables. So 18 of the observations from the permanent SAS dataset SES score were from Clinic A, and so they were outputted to the Clinic A temporary dataset. And 29 observations were from Clinic B, so they were outputted to the Clinic B dataset, and so forth. So in this example, we have used 4 output statements to create 4 temporary SAS datasets. Each dataset has just 3 variables: PTID, clinic, and RAN date. Let's say we were interested in matching observations from one dataset with observations from another dataset. So let's say we had a dataset of baseline information on a group of patients, and we wanted to merge that dataset with follow-up data on the same group of patients. To merge 2 datasets, we need to use the merge statement. And the way the merge statement works is that it matches observations from one dataset with observations from another. And in order to do that, it has to have a by statement, and the by statement must be the same name and type on both datasets you want to merge. So if you want to merge based on patient ID, then patient ID needs to be either a numeric or a character variable, and it's got to be the same on both of the datasets that you want to merge. So if patient ID is numeric on dataset 1, then patient ID needs to be numeric on dataset 2 in order to merge the 2 datasets. Otherwise, you'll get an error. So what you're going to need to do first when you want to merge 2 datasets is you're going to need to sort each of the datasets by that common variable. For example, patient ID. If 2 datasets are merged with common variable names besides the by variable, variables from the second dataset will overwrite the same name variables from the first dataset. So let's say you have a variable on your first dataset, such as BMI, and then you have the same variable BMI on the second dataset, and you're merging by patient ID. BMI from the second dataset is going to overwrite the BMI on the first dataset. And we'll look at examples of that when I do the SAS demonstration video. So here is the typical code you will see when you want to create a merged dataset. First of all, we're sorting 2 different SAS datasets. We're sorting a baseline dataset and a dataset called follow-up. And for each of those datasets, we're sorting it by ID. Then we're creating a new dataset, data all, and we use the merge statement. So we're merging baseline and follow-up by ID. It's very, very important that you include the by statement. If you leave out the by statement, the program will run, but the results will not look as you would expect them to look. Now what if I only want observations that are in the second dataset? So in this example, I'm creating a new dataset called deaths, and I'm merging my baseline dataset with my follow-up dataset, and I'm only interested in keeping the patients that were in the follow-up dataset. As it happens, these patients were patients that died. And so we only want to keep those patients who are in the follow-up dataset in our new dataset that we're calling deaths. How do we do that? The way we're going to do that is by using a contributor variable that's called in equals. And what it does is it gives us control over which observations are added to the merged data set. Basically, in1 is going to equal 1 if that data set, the baseline data set, has made a contribution to the current observation. And what I mean by a contribution is it has a non-missing value for the by variable. So if a patient ID was on the baseline data set, then in1 would equal 1. If a patient ID was in the follow-up data set, then in2 would equal 1. And the variable names in1 and in2 are just variable names that are used in the data step. They are not actually outputted to the new data set. So here what we're saying is if you came from the baseline data set, in1 equals 1. If you came from the follow-up data set, then in2 equals 1. And we're only interested in those observations that came from the follow-up data set. So we're making the statement if in2, which is the same as saying if in2 equals 1. So we're only keeping observations that appeared in the follow-up data set. And those observations would have been merged with the baseline information. And so what we've created is a data set that only have patients that died. So let's look at this in terms of logical statements. If we are only interested in subjects that appeared in the first data set, we would write the statement if in1, which is the same as saying if in1 equals 1. If we are only interested in keeping observations that appeared from the second data set, then we would write the statement if in2. If we were interested in only keeping subjects that were in both of the data sets, then we would write the statement if in1 and in2. Another way of visualizing these logical variables is with this Venn diagram. So here we have our two data sets, dataset 1 and dataset 2. If a particular observation had data from both of those two data sets, then both in1 would equal 1 and in2 would equal 1. And so going back to our example of merging together baseline data with follow-up data on patients, and where we were creating a new data set, death, then a patient who was in both the baseline data set and in the follow-up data set would appear in the intersection of these two data sets. If the patient was just on the follow-up data set but not on the baseline data set, then it would be this area that doesn't overlap between the two data sets, dataset 1 and dataset 2. And similarly, if the patient was only on the baseline data set and not in the follow-up data set, then the contributor variables would take on the values in1 equals 1 and in2 equals 0. This concept is a little bit complicated, and I think it will be more clear when we look at examples in the SAS demonstration video of how we merge SAS data sets. The last thing I wanted to mention in this video was an automatic variable called _n_. And this is a helpful variable that can be used, and it's only available in the data step. This variable is not outputted onto your data set. It's an internal SAS counter which contains the current iteration number of the data step. So when the program starts, the variable _n_ has a value of 1. And each time we go through the data step, each time SAS goes through the data step and processes a subsequent observation, then this counter gets bumped up by 1. And you can actually use this _n_ as a variable in the data step. So you could write an if-then statement. For example, if _n_ equals 1, then take some kind of action. Here is an example of how we use this automatic SAS variable in a data step. we're creating a data set called March 10, and we're just interested in selecting the first 10 observations that appeared in the SAS temporary data set March. So we're using the _n_ to select out just those first 10 observations. And we see here in our SAS log that there were 635 observations read from the dataset work.march. This was the dataset I used in the SAS management video. And that our new dataset, March 10, has just 10 observations and 13 variables. And the 10 observations that were selected were the first 10 observations that SAS processed in the data step. Now view the SAS demonstration video, Combined Datasets. And lastly, view the SAS demonstration video, SPSS to SAS.